Good afternoon, students. Today we're going to talk about documenting our code using XML comments. So these are a style of comment that Microsoft has provided to us that uses these triple slashes. So it's effectively a double slash comment with an extra slash. And then inside of it we use these XML tags like summary, which describes what a class is doing. So this article on the Microsoft's Developer Network Documentation shows us all the possible tags that exist within this XML. And why we care about this is we want to do a good job of documenting our classes so that when other programmers come and read our classes, they can see what those classes are doing. But the other reason we really want to do this documentation in this style is that plugs into Microsoft's IntelliSense. So this is actually used by Visual Studio to give you information about the methods, the functions, the properties, all of the things that you're working with. So all of those kind of tooltip things that Microsoft does are based on this. We're going to start with this little starter project we're calling Documentation Exercise. And you can see we have one class declared in it, which represents a planet. We have a static class list operations, which declares a number of methods that are also static methods, so basically a library, kind of like the vector module that we played with early in this semester. And the program is a console application, so we just go through and we invoke a lot of these operations that we've defined on some various different types of lists. So a list of numbers, which are ints, a list of strings, which we use for fruits, an empty list, and finally a list of the planet objects that we've defined. So for example, if we hover over this planet, notice how it says class documentation exercise planet. It doesn't really give us any additional details. Now if we come to the planet and we actually start doing our documentation process, so we do triple slash, and notice also by default Visual Studio will go ahead and inject the summary element there for us. And here we just type what we want to describe this as: a class that represents a planet. Save that, and if we were to go back to our program and now hover over planet there, notice that it now tells us that this is a class that represents a planet. So it's pulling those comments directly into our IntelliSense and giving us a little bit more information about that. So at the bare minimum, we want to have a summary at the top of every class. And then for each property that is at least public facing, and really we should do it for every property, we want to give it a description. Here, instead of summary, we're going to use value. So the auto completion isn't smart enough to sort between if this is a property or if this is a class. But here we're going to give it a value for what this name is, the name of the planet. And if we were to come back over here, now notice that we aren't actually using that anywhere, so let's just slip in and it's 0.name, and now if we were to hover over that, it tells us the value is the name of the planet, so it goes ahead and pulls that for us. Okay, let's finish documenting our class. And this is why, for example, we would want to document this, because we hit radius. And when we think about a planet's radius, how are we measuring that? Are we measuring that in miles? Are we measuring that in feet? Are we measuring that in millimeters, kilometers? You know, what is the unit that we're actually using? Now, that's not expressed here in the name, so we want to definitely add some detail there. Actually, let us know what that is. So the radius of the planet measured in, and what exactly is that? Well, let's go look at our program. When we define our planets, notice Mercury is 0.329 for a radius, Venus is 0.9499, Earth is 1, 1, 1, 1 across the board. That kind of is a dead giveaway. We're actually measuring all of these values in relation to the Earth. And there is a term for that. That term is Earth radius. Earth radius is the distance from the center of the Earth to a position on its surface, which is about 6,000 and change kilometers. And it uses this funky symbol. And then we can measure other astronomical bodies based on their ratio of comparison to that number. So this is the Earth radius, and measured in Earth radius. And it's the same thing for the other three. Volume of the planet, measured in Earth volume. And finally, gravity. Okay. Now we get down to the constructor. The constructor will normally take a summary, and notice too that as soon as we hit that third slash, not only did it create the summary for us, but it pulled all of the parameters that were declared and created a param element for each one of those, and each one has a name attribute which is set to the corresponding name of the parameter. So this actually does a lot of the work for us. So we can say creates a new planet, the name of the planet, the radius of the planet, in Earth radius, the volume of the planet in Earth volume, the mass of the planet in Earth mass, and the gravity of the planet in Earth gravity. Okay, so that gives us all of those properties are now properly defined and declared. And then we have one method, which is an override method, which is overriding the toString, which is defined on all objects, so that when we invoke toString on this, we're going to return the name of the planet. Let's go ahead and do that. And notice that it automatically generates for us a returns, because now we have a return value, which is a string. So converts the planet to a string. And what we're returning is the name of, at least at this point. And we can tweak how that would work if we wanted to maybe give the name and the mass or something along those lines. But this is exactly how we need to document a class. We should always document a summary for all of these different things we looked at, or our accessors. We're supposed to use a value, and then we can do summary returns. We can also do more nuanced descriptions with the remarks. The remarks are for giving kind of a greater amount of detail. Planet keeps track of radius, mass, gravity, and was there anything else? Volume. Radius, volume, mass, and gravity in relation to those of, we should say, in proportion that of Earth. Okay, now if we go back to our program and we hover over Planet Now, notice that it also gives us that extra bit of detail, but that bit of detail is kind of pushed down a little bit. So the real focus is class that represents the planet, and then we're giving a little bit more detail. We could also put in examples into any of these, kind of showing how they might be used. With an example tag. And the reason we do this is when we generate documentation from it, like if we go look at the C# documentation for classes, for example, notice that they have declaring classes. You can actually generate some documentation like this, and those examples would be embedded into it. Example would give us some code to work with. So you can actually add quite a bit of detail and interesting stuff in here. We could also show that format these as code by putting C's around it. C element is for inline code, and I misspelled radius in there, which if we look at it over here, notice there's no difference, so that really doesn't affect the IntelliSense. But if we turn around and generate some documentation out of this, then it would look a bit different. It would format this as a code comment. So those are some of the additional things you can do. But this is kind of the bare minimum you should be doing with all of your classes, is we want to document a summary at the top of the class. Every property should have a value element. Every method and constructor should have a summary. If it takes any parameters, all of those should be listed. And if it has any return value, that should also be specified there. So that is the expectation. Now let's go ahead and take a look at our list operations. So this is a library of operations to perform on lists. And specifically, these are generic lists. Notice that we have a T in. So one of the things we can look at here, we can look at the name, we can look at this. This is a static method, clearly. And then this is also a template method. I don't know if you've covered these, but basically we're saying this print works with some kind of type, which is represented by T in that angle brackets, which can be different types at runtime. And then the list also has that same T. So we're saying this will take a list of some kind of object. We're not sure what kind of object that is until runtime. This is what makes it a generic. So this is a generic method working with a generic list. And we can also do constraints, like adding a where T maybe is a planet. If we did that, then only planets could be put in this list. So we'll probably dig a bit deeper into generics down the road. What we really want to do right now is just document this. So if we look at this method, we are printing, and if we look at this code in here, first we do a check to make sure the list isn't empty. And if it isn't empty, then we're going to iterate over the list -1. So we're going to stop one element before the end of the list, and we're going to use console.write to write out the item in the list. Because it's being passed to console.write, that will invoke the toString on this. And then we're writing a comma followed by a space after that. And then after we get out of this loop, we are printing the very last item in the list. This is just a trick to add a comma after everything except the very last character. So it looks like this is printing a list. If we go ahead and look at our program, we can kind of double check that idea. So here, when we work with numbers, we're creating a list of numbers. New list, notice that we're using the type int. And we're using this initialization syntax, which just goes ahead and populates that list with these items to begin with, so the numbers 1 through 10. And then we're writing to the console the list of numbers contains, and then we're invoking that print. So if this does what we expect it to do, it should print this array on that next line. Go ahead and run this. Notice that our first line, we're running that documentation exercise. The list of numbers contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in order, which matches up with what we have there. So the print does exactly what we thought it would do, which is prints the list as a single comma separated, single line of comma separated values. Okay, and then we have the type param, which is the type of the list items, and then we have the list itself, which is a list of items to print. And we can also do a param ref of name list. If we do that, that means this is going to bind a reference to this parameter in that spot, and that works for code formatting. In our IntelliSense, notice it just says, where's our print? There we go. Prints the list, and notice that list is actually highlighted in a different color, which matches it in the parameter list. So we've just basically acknowledged that that's what we're actually modifying there. Okay. Our next method is average. Again, it's a generic method. We check to see, first of all, if the list count is 0. So if we have no items in the list, we're going to throw a divide by 0 exception, because the count, obviously down here, we're dividing a sum by the count, and if the count is 0, we're dividing by 0. So we're preventing that way up in the front. And then we create a sum and we iterate through the list, and we're basically going to take that list and add it to the sum. And this dynamic cast here, we're actually casting this to a dynamic type, which we're going to talk about next week. So you don't need to worry about this too much. It basically just lets us use a generic, and it puts off figuring out what it actually is until runtime. So that's that method. Let's go ahead and document it. And notice that it gives us the type param again, it gives us a param, and it gives us a return value. So we're going to say this computes the average of the list. And let's do a rel or param reference there for that list. And the type of the list. And then the name, or this parameter, is the list of items to average, and the return value is the average of the items in list. And we can again do a param ref pointing at that list. Now we're not done. This is all the fields that C# gave us automatically, but we know that there's a possibility we're going to throw this divide by 0 exception. And if we know that there's a possibility of throwing an exception, we need to document that. And we do that with an exception element. And notice it wants to give a cref. This is telling us what particular exception is throwing, which in this case is a divide by 0, which is part of the system namespace. A system.divide by 0 exception, and most of the exceptions, unless you write your own custom exceptions, are going to be in that system namespace. And we'll just say thrown if the list is empty. And then we might come up here and say the average computes the average of the non-empty list. And we might put that in the parameter here. List of items to average should not be empty. So that gives the programmer a little more knowledge about how we should be using that. If we jump back to our program and now we look at the average operation, we're pulling right here. Notice that it says returns the average items in the list, and it has the possibility of throwing a divide by 0 exception. And if we come down to working with the empty list, when we defined an empty list, notice that we've put this inside a try catch, so that if we try to calculate this average, we should catch any exceptions that happen. If we go back to what the console outputted, notice that list empty contains nothing. We invoke do1, do2, do3 on empty. They all contain nothing. Invoking average on empty throws a, and then we're passing an e to the string concatenation, and it's going to print out what the toString of that exception is, which is telling us that this is a system divide by 0 exception, as we attempted to divide by 0, and it gives us a little bit of the stack trace saying where that happened. Okay, so that was the second operation there. Then we have these do thing 1, do thing 2, do thing 3. Not very clear what those are doing. So we need to comment these. This is an example of poor naming strategy, obviously, because what the name should really say is something that reflects what that operation does. But I actually left this deliberately obtuse because I want you to figure out what this operation actually does and add the comments that describe what it does as well as what parameters it takes. None of these throw exceptions, so you don't need to worry about exceptions, but you do need to read through this code. And you can also take a look at the output and try to figure that out. For example, the list of numbers was 1 through 10. The average was 5.5. After we invoked do one thing, the list was now 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So what did that operation do? That's what you'll document here above this method, and then you're going to add documentation for do thing 2 and do thing 3. So figure out what those do and go ahead and write those up. Now there's one more thing I wanted to share with you before we moved on. Notice that we're using the auto number syntax here for these properties, but we're actually marking the setter as private. So this is something we can do with setters. We can actually declare them to be public, but then actually set one of the getter or the setter to be private, or potentially both, to basically override what the default is that would be applied to both. And the benefit of this is now the only code that's allowed to invoke our setter is the class itself, the class that owns this property. So this is effectively now a read-only property. Outside of this class, we're not allowed to set it. So if I came back to over here and created a planet, or actually just used one out of my list of planets, and I tried to set maybe the radius, set it equal to 3. Notice it's going to underline that in red. It's going to tell me that the property indexer cannot be used in this context because it's inaccessible. In other words, this is a read-only setter, but it is one that I can actually read from. So I can actually print the value, but I can't set the value. And if we go back to the planet, we do that with all of these, and notice that we actually set those here in the constructor. And we can do that here because that code is in the same class. So this is actually setting these private setters to the values we pass in. This also means the entire planet is effectively read-only. We might specify that after the planet is created. And let's go ahead and capitalize that because that is a class name. And there we go. So this is the kind of documentation you're going to be doing on your milestones, and basically every code that you write in this class, you should be doing this level of documentation. And that's something that we are going to be grading against. So go ahead and finish up these last 3 functions, give them their documentation. Once you've done that, you can push your changes back to your cloned repo on GitHub, and then create a release and go ahead and turn in that release. And if you don't remember how to create a release, the documentation up on Canvas walks you through that. So just find the GitHub workflows, and you're going to want to commit your changes, push it to origin, create a release, and then give us the URL of that release as how you're turning in your assignment. Thanks for your time. Stay healthy.